Hi everyone, good day to all of you. Welcome again to our basic calculus class. My name is Sir Dennis. Our lesson for this week is about the limit laws. Limit laws is still under our unit number 1 entitled Limits and Continuity. So for today, we're going to solve additional examples or mathematical problem that involves limit of a function. The instruction is evaluate the following limit without using the L'Hopital's rule. So meaning to say, we're going to determine the limit of 2x squared minus x minus 3 all over x cubed plus 1 as x approaches negative 1. So before we solve this problem, let us review first our previous topics. We're done discussing about the limit laws. So these are the theorems on limits that are proven to be true on finding the limit of a function. We have the theorem number 1, the limit of a constant. Our example is this one. Limit of 4 as x approaches 2 is 4. Then limit of 9 as x approaches 6 is also 9. We also have theorem number 2, which is the limit of identity function. Our example is limit of x as x approaches 5. The answer is 5. Limit of x as x approaches 8 is equal to 8. Then we have the theorem number 3, which is the limit of a constant times a function. Our example is limit of 4x as x approaches 2. By applying the theorem, the answer for that is 8. Also, we have the theorem number 4, which is the limit of the sum of two functions. Our example is limit of x plus 7 as x approaches 2. By applying the theorem, the answer is 9. Then, we also discussed theorem number 5, the limit of the difference of two functions. Our example is limit of x minus 5 as x approaches 3. The answer is negative 2. Next, we have the theorem number 6, which is the limit of the product of two functions. Our example is limit of 3 times 2x plus 1 as x approaches 2. By applying the limit, our answer for that is 15. Then we also have additional example for that, theorem number 6. Limit of x times 5x plus 4 as x approaches 3. Also, by applying the theorem, the answer for that is 57. The next theorem that we discussed is theorem number 7, which is the limit of the quotient of two functions. Our example for that is like a rational function. So limit of 2x plus 5 all over x plus 3 as x approaches 2. By applying our theorem, so the answer for that is 9 over 5. Also, we have additional example for theorem number 7. Again, another rational function, the limit of 5x plus 4 all over x plus 1 as x approaches 2. Again, by applying the theorem, the answer for that is 14 over 3. The next theorem is theorem number 8, which is the limit of the nth power of a function. So meaning to say this involves exponents. So our example for that is limit of 3x plus 4, the quantity rather of 3x plus 4 raised to 3 as x approaches 1. The answer for that is 343 by applying the theorem. Then additional example for theorem number 8, we solve limit of the quantity of 4x plus 9 raised to 2 as x approaches negative 3. So by applying again our theorem number 8, the answer is positive 9. Next to that is the theorem number 9, which is the limit of the nth root of a function. So this involves radical, which is root of a function. Our example for that is limit of the cube root of x squared plus 4 as x approaches 2. So by applying our limit laws, the combination of different limit laws, the answer for that is 2. Lastly, we have the theorem number 10, which involves polynomial function. It says that if the function is a polynomial function and the certain value of x is a real number, then we're just going to substitute the value of x. Just like on this example, find the limit of 2x minus 8 as x approaches 5. So this is a polynomial function and this is the certain number 5. So we're just going to substitute the value of x. So that is 2 times 5 minus 8. 10 minus 8, the answer is 2. So those are the 10 limit laws that we discussed last meeting. We're going to apply it to different functions. Evaluating limit of a function using the limit laws. Example number 1, find the limit of 3x squared minus 4x plus 5 as x approaches 2. So this is the sum and difference of a function. So we separate their limit. Then we also apply other limit laws that is applicable to them. So we use limit of a constant, limit of constant times a function. Also, we have exponent rule. Also, we can apply here the theorem number 10, which is the substitution, since our given is a polynomial function and the certain value is a real number. So we're just going to substitute 2 to the value of x. That is 3 times 2 squared minus 4 times 2 plus 5. That is 12 minus 8 plus 5. The answer is 9. Again, example number 2, find the limit of 4x cubed plus 5x squared minus 3x plus 8 as x approaches 2. So as you can see, we apply again different limit laws. So we use the sum and difference of a function. We also use the limit of a constant times a function, and limit that involve exponents. But we can also use again the theorem number 10, which is substitution of the value of x. Since the given is 4x cubed plus 5x squared minus 3x plus 8, which is a polynomial, and the certain value of x is a real number. So what we're going to do is substitute 2 to the value of x. That is 4 times 2 cubed plus 5 times 2 squared minus 3 times 2 plus 8. By simplification, that is 32 plus 20 minus 6 plus 8. The answer for that is 54. Now, let us discuss additional examples like we have on the first slide. What if the given function is a rational function and the limit will lead to an undefined or indeterminate value, just like this one? Find the limit of 2x squared minus x minus 3 all over x cubed plus 1 as x approaches past negative 1 rather. First, if we're going to use the theorem number 7, the limit will be indeterminate. As we can see rather, this is a rational function. This involves quotient, which is theorem number 7. But if we're going to use that, the limit will be indeterminate because the denominator will be 0. So this is our problem. Limit of 2x squared minus x minus 3 all over x cubed plus 1 as x approaches negative 1 by applying theorem number 7. So we separate the limit of the numerator and the limit of the denominator. So by applying again our theorem number 10 on this one, because this is a polynomial and the denominator is also a polynomial, we're just going to substitute -1 as the value of x. For the numerator, the limit will be 2 times -1 squared minus -1 minus 3. And for the denominator, -1 cubed plus 1. By simplification of that numbers, that will lead to 2 plus 1 minus 3 all over -1 plus 1, which is 0 over 0, indeterminate. On that case, we're going to do additional method. So what we need to do is to simplify the given function by factoring. Our original function is 2x squared minus x minus 3 all over x cubed plus 1. We're going to factor the numerator and the denominator to eliminate the denominator that will lead to 0. So that is the factor of this numerator is 2x minus 3 times x plus 1. Then the factor of this denominator is x squared minus x plus 1 times x plus 1. So this factoring is the application of what we learned in junior high school. Now, since we have a common factor, we have x plus 1, then we're going to divide it. So this will be divided. We will left with the simplified form 2x minus 3 all over x squared minus x plus 1. After the simplification, we can apply again theorem number 7 because our simplified form is 2x minus 3 all over x squared minus x plus 1, which is also quotient of two function, which is also a rational function. So find the limit of this function as x approaches -1. Again, by applying the theorem number 7, we're going to separate the limit of the numerator and the limit of the denominator. Since our numerator is a polynomial function and the denominator is also a polynomial function, we're going to use theorem number 10, which is we're going to substitute -1 as the value of x. For the numerator, that will be 2 times -1 minus 3 all over, for the denominator, that is -1 squared minus -1 plus 1. By simplification of this number, this will be 2 times -1 is -2 minus 3. Then on the denominator, -1 squared is 1. Then -1 times -1 is +1, then plus 1. Simplifying further the number, we have -5, which is -2 minus 3 is -5. Then the denominator is +3. So the answer is -5 over 3. Therefore, the answer for our problem is the limit of 2x squared minus x minus 3 all over x cubed plus 1 as x approaches -1 is equal to -5 over 3 by using our limit